know if something doesn't make sense. Cool? Okay. So before we get started, well, I guess you know what? Let's just read the question. Question number 1. The function y equals f of x is graphed below. Plot a line segment connecting the points of f where x equals -3 and x equals 2. So I'm going to go to -3, and I'm only seeing the y-axis is going by 2, the scale. So -3, -2, put a point there. And then at 2, you're going to put a point as well. And that looks like it's 2, looks like it's 10. So 2, 10. And then connect those 2 points. This is called, and I didn't make it perfect, my bad. This is called a secant line if it goes through 2 points on the curve like so. What is that line called? A what? A secant line. S-E-C-A-N-T. Secant line. I don't know why mine doesn't look quite as straight. Okay, you read a graph left to right. Obviously, my slope is positive. So from negative, let's see, where am I at? -2 all the way to 10. The difference in y is 12. Does everyone see how I got that? I guess I'll put the point here. No. Guys, that was a joke. Sorry. I apologize. All right. So let me go ahead and put these points here, guys, because maybe you guys are better visual learners. Guys, focus. 2, 10. Okay, here's what's happening. I was at -2, and now the y value is at 10. How much did the y value change by? 12. So I put a 12 there. I was at -3, and now I'm at 2. So that means I moved 5 times to the right. So my change in x is 5. Sometimes they call this vertical displacement. Sometimes they call the delta x horizontal displacement. Change in y, all that means is y2 minus y1. Change in x, all that means is x2 minus x1. Any questions so far, guys? Okay. Next, average rate of change. That literally means what is the slope of that secant line. So let's see. 12 over 5, done. Was that okay? Is anyone confused? Okay. Let's go to the next one. Observe the scale on the y-axis, guys. So it says the function y equals f of x is graphed below. Plot a line segment connecting the points on f where x equals -2. So I'm going to go to -2, 5, put a point, and 3. So I'm going to go to 3, looks like it's -10. Make a line segment. What is this called? This line here? It's a secant line. This point up here is at -2, 5. This point down there is at 3, -10. So here we go. I went from 5, the y value of 5, to the y value of -10. How many spaces did you go down? How many? 15. So you're going to put a -15 because you went down 15 spaces. Are we cool? Left to right, you went from -2 to 3. So how many spaces did you go to the right? So, -15 over 5. Average rate of change, -15 divided by 5, which is equivalent to -3. It is going downhill, so the slope is negative. Does that make sense, guys? Okay, nothing crazy, right? All right, go to the top right-hand side. Look what it says. It says for the function f of x equals -2x squared plus x plus 6, find the slope of the secant line. So all you're doing is this. F of 4 minus f of -1 divided by 4 minus -1. All I'm doing is y2 minus y1 over x2 minus x1. Go ahead and turn on the AC. Push that little button. Does that make sense, guys? Okay, here we go. Go to the side. You're just going to write f of 4 equals, let me see if I have enough space there. So let me rewrite it. f of 4 equals negative 2 parenthesis 4 close it squared plus parenthesis 4 close plus 6. You can just drop the parenthesis. Well, negative 2, 4 squared is 16 plus 4 plus 6. Drop those parentheses, right? Negative 2 times 16 is negative 32. And then 4 plus 6 is 10. And then negative 32 plus 10, I believe that's negative 22. See? It can be done without a calculator, guys. You guys are good. So here we go. I'm going to do f of negative 1 over here on the side. F of negative 1 equals negative 2 parenthesis negative 1 squared plus parenthesis negative 1 close plus 6. Negative 2. Negative 1 times negative 1 is a positive 1. And then this turns into a minus 1 plus 6. Let's see. Negative 2 times 1, that's a negative 2 minus 1 plus 6. Here we go. Negative 2 minus 1 is negative 3. Plus 6 is a positive 3. Alright, I think I've done everything. Here we go. I come to this equal sign. I plug in what f of negative 4 is, negative 22. Minus this guy, 3. Over 4 minus a negative, it's going to turn to a positive, so plus 1. So 4 plus 1 is 5. So now I have negative 25 over 5, which is equivalent to negative 5. You don't have to show all those details. If you know what you're doing, just go right to the answer. I'm just trying to show all the little details for you guys so you guys know where everything's coming from. All right. Are we still okay? All right. Again, I'm doing the same thing, guys. All I'm doing is f of 2 minus f of negative 2 all over 2 minus negative 2. They just want the slope. I come to the side, I write f of 2 equals 2 times 2 squared minus 2 plus 2. I see those zero out. 2 squared is 4, 4 times 2 is 8, so I see 8. I go to f of negative 2. 2 times negative 2 squared minus a negative 2 plus 2, so they don't zero out now. So let's see, negative 2 squared is 4, 4 times 2 is 8. Minus a negative is a positive, so I see plus 2 plus 2. So 8, 9, 10, 11, 12. So I see 12. Okay, I'll slow down. I come up and I go f of 2, which was 8, minus f of negative 2, which is 12. All divided by 2 minus negative 2, which is 4. The difference between 8 and 12 is 4. The 12 is larger, so it stays negative. Negative 4 over 4 is negative 1. That's your average rate of change. It's also your secant line slope. Ask me questions, guys. Are we okay? Is this coming back to you? Okay. Use the graph of the function f of x to fill in the answers to the question. Okay. All right. Before we start that one, let's talk real quick about rates of change. I'm gonna do the easy ones. So I'm going to talk about increasing function, and I'm going to call this number 1, and increasing function, and I'm going to call that number 2. All right, on number 1, is the function increasing at an increasing rate, or is it increasing at a decreasing rate? Yeah, maybe you've heard of this in physics. I want you to look at those tangent lines, and look how those slopes just keep getting steeper and steeper. This is like a slope of 2. This is like a slope of 4. This is like a slope of 6. Look at those numbers, 2, 4, 6. So, isn't 2, 4, 6, isn't those increasing? So that's what you call increasing at an increasing rate. So number 1 is increasing at an increasing rate. Make sure to put the word R-A-T-E. What about number 2? Yeah, look, that's like a slope of 6. This is like a slope of 4. This is like a slope of 2. Notice, look at the slope. 6, 4, 2. It's decreasing. Do you guys notice that? So this is increasing because you're still going uphill at a decreasing rate. Notice the concavity. So write this down somewhere. Hopefully all this is review. If you're concave up, that's an increasing rate. If you're concave down, that's a decreasing rate. All right, let's see what this one wants. Between -7 and -3. So it helps to draw vertical lines. Here's -7. Here's -3. So I'm only looking at this in sky blue. What's happening there? Am I increasing or decreasing? Am I going uphill or downhill? So I'm going uphill, increasing at a what type of rate? At a increasing rate. It's concave up, guys. It's concave up. You're increasing at an increasing rate. Cool or not cool? All right. Let's go to the next one. Don't worry, guys. We'll be done pretty quick. I know everyone's tired from being up all night from your seminars and all that good stuff. Here's 3. Here's 7. Look at this curve, guys. Are you going uphill or not? You're going uphill. What's the concavity? Concave up or concave down? So you are increasing at a perfect. You are increasing at a decreasing rate. That's why you're able to have a horizontal tangent there at the very top, because you're increasing at a decreasing rate. Does that make sense, guys? Okay. Hey, no. That's a demerit. All right, here we go. It gets easy, guys. It gets easy. Concave up, concave down. So look, they want to know which one of these are concave down. So it looks like letter D for sure. And then maybe letter B. I'm going to put question mark because that looks like it could be a point of inflection where it changes from concave up to concave down. No, that looks like it could be. Yeah, it looks like it's concave down. Does that make sense, guys? Because look, it almost kind of looks like here's concave down right here, all that stuff. And then I see concave up. So it almost looks like it's a point of inflection. It's right on that edge. I want to say it's leaning more towards concave down. Letter D is concave down for sure. 100%. It depends on the sensitivity. Cool or not cool? Let's go to the next one, guys. Number 8. Number 8 is more obvious. It says, identify all points that fall in the intervals where the function is concave up. That one for sure, it's letter what and letter what? B and D, 100%. There's no confusing those. Definitely concave up at those two. Yay or nay? Cool. Let's go to the next one. Oh, by the way, in case you don't know, this is concave up. This is concave down. So just making sure you know, guys. Hopefully all that's a review for you guys. All right. We're almost done. The given function is defined on the interval -9 to 9 and represented by the graph below. Find the x values at which the minimum value of f of x occurs. Okay. I just want the min at where f of x occurs. Where do I have minimum values? For sure, -1. And I want to say -9 is a relative min. And I want to say that 9 is a relative min. Sometimes I don't call those relatives. But isn't this the lowest point in the vicinity? And isn't that's definitely the lowest point of the vicinity. And isn't that the lowest point in the vicinity? So all these three I would count as relative as mins. X equals -9, 1, and 9. Oh, do they want the absolute min? Okay. Never mind. Find the x-coordinate which the minimum value. Okay. Hold on. If it doesn't tell you anything and it just says where the minimum value happens, that means absolute. Yeah, global. So it's going to be, which one's the smallest one? -9. Find the x values at which the minimum value of f of x occurs. Yeah. -9. There is no other smaller value. All right, go to the next one. All right. I'm glad that they distinguished. Don't worry, there's the last one, guys. Find the x values of the local minimum. So that just means wherever you have minimums, everywhere. For sure at -3. Where else? 3. Those are local minimums. In the vicinity, those are the lowest values. And that's it. Was that pretty easy, guys? All right, that's it. Take out your deltas. Let's practice, and we're done. Good job, guys.